In the previous video, we have created our road, and it isn't perfect, so we have to deal with this, that some parts of the road needs to be changed into different prefabs. So how should we go about it? Let's stop the game, and what we need to do is to create two additional scripts that will be helper scripts. So first of all, let's create a C# script called direction. And let's open it up. So this will be an enum. Instead of model behavior, delete everything from the content of this class. Now it is an enum, and we will want to have the cardinal directions here. So up, down, left, and right. Let's save this. Let's go back to Unity. That's everything for this direction enum. Okay. And we will need to have an additional class. Let's create a new C# class. Let's call it placement helper. Okay, let's open it up. Great. And this will be in turn a static class. And we do not want it to be a mono behavior. So this will be a plain C# class. This placement helper will be used for road helper and for our building helper that we will implement very soon. For now, what we need here is to implement one static method, and this will be find neighbor roads. So public static list of directions. I need to be using system collections generic. So list of type direction. And probably we should call it find neighbor. Okay. And we will pass here vector3 int position. So this will be the position for which we want to find the neighbors. Next, we will pass I collection. So we want to pass an interface instead of list or dictionary or whatever collection type we could pass here, because we will use it with both the road helper and the building helper, and they both will have different collection types, but they all will implement iCollection interface. That's why we are using the generic iCollection type, and we are going to choose a vector3 int for its type, and we are going to call it collection. Okay, great. Those are all the parameters, the arguments that we will pass to this method. And we will need to return a list of directions. So let's create one. List of direction. We will call it neighbor directions. Equals new list. Okay. So basically the idea is that we will return a list of directions in which they are neighbor. And this will be the road neighbors. So we'll know, okay, there is a road to my left, to my right, and downwards. So we will need to use a prefab that is a three-way road. And if there are 4 neighbors, then we will need to use a prefab of type 4-way road. Now, how do we perform it? Well, we need to perform a couple of checks. So let's type if collection contains, and we'll basically need to check the position of in every direction. So our position plus the offset, which is vector3 int. First we will check to the right. So right means on x-axis. So we will check on x-axis to the right if there is a road or any other neighbor, depending on what we pass as the collection. But for now we will work with road, so we are going to check if there is road to my right. If there is, we are going to add neighbor directions. Add, we are going to pass direction dot right. Okay, next, if we can copy this multiple times and paste it here. So we need 4 times because there are 4 cardinal directions. And next we are going to check to the left, so minus vector3 int right. If there is, we are going to pass a left in the second if statement. Next, we do not have vector3 forward as you would expect, but we do have one in vector3. So we need to create new vector3 int 0, 0, 1, and we will basically use that, and we need to pass another brackets to finish it off, and we can copy this and paste it down here, because here down here we will need to change plus for minus. Control K, Control D to format the statements, and here we are adding not right but upwards, so up direction, because we are checking on the axis, which in our context is up, and here we are checking on z axis downwards, so we are choosing down direction. Okay, great. And we will return at the end the neighbor's direction, neighbor directions. Great. So that's it for our placement helper. Now we need to go back to Unity, and let's open up the road helper. Okay, and here we will need to create a new public method, public void xRoad. This won't take any parameters, but what we need to do is to go for each our position in our xRoad candidates, so in our hash set. Okay, great. And by the way, we have used hash set here because hash set doesn't take duplicates, so we ensure that we only go once through a position. So having this explained, let's create a list of directions, neighbor's direction, or neighbor directions. Okay, and this will be equal to our placement helper, and since this is a static method, we can call on it find neighbor, position, road, dictionary dot keys, because this is also of type iCollection, and basically those are all the parameters we need to pass here. So we have received the list of neighbors that are near this position that we need to check if needs fixing. So now again we need to create quaternion rotation, and let's set it to quaternion.identity. So before we go any further, let me go back to Unity. Okay, and I haven't explained it well. So road straight, let's click F to focus on it, has basically the rotation to the right as the default, and this is the quaternion identity rotation. And we said that if the movement was on x-axis, we wouldn't change it, but if movement was on z-axis, we would add 90 degrees on the y-axis in rotation tab, and this would rotate it like this. And if we had road that goes up or down, we would have this rotation. Now, each and every one of those prefabs for other types of roads will have a different basic rotation. So, for example, corner is rotated to the left and upwards by default. Three-way street is rotated upwards, downwards, and to the right. So, what we will need to do is figure out where are the neighbors to decide what rotation should we apply to the prefab to have the correct rotation. Of course, the four-way doesn't need any of that, and that's basically the whole idea. We also have the road end, and this is the same story because we will need to rotate it depending on where is the neighbor. So up, down, left, or right. Okay, so with this digression out of the way, let's go back to code. So this will be a little bit of work because now we have to check if our neighbor directions.count is equal 1, then we know that we need to spawn the road end. Else, if our neighbor direction.count is equal to 2, then we know that we can stay with the straight road, or maybe we need a corner. So what would we do? We would check if our neighbor's direction contains the direction dot up, for example, and at the same time we can copy this statement, and doesn't contain up because it contains up with capital letter, and down. Okay. And we need or. We can copy this statement and change the directions. Okay. Paste it here. Instead of up and down, we are going to pass right or left. So in those cases, we are not changing anything, so we can type continue. Because we have a straight road, so as it is. Okay, great. But else, we will need to consider how to place a corner. Next, else if, we are going to check neighbor's direction dot count is equal to 3. If it is, we will have to consider how to place our three-way street. And else, we will place our four-way street. So this would be quite easy. We would need to destroy the current game object. So to do that, we need to access the road dictionary, add this position, and we have destroyed this object. And what we would need to do is call road dictionary at this position that we are checking, and we would need to do instantiate, and we would need to call road four-way position and our rotation, which is just quaternion.identity, and our transform as the parent, so it is placed under the road helper game object in our hierarchy. Okay, so we have dealt with the four-way street. Now we need to see how to rotate a road end, a three-way street, or a corner. So let's start with the road end. This will be the simplest one because, again, we need to call destroy the road dictionary on this position, and we are not calling destroy at the beginning because we have one case where we do not want to destroy this. That's why we are calling destroy at each stage instead of on the top of this if statement. So we have destroyed the road, and now we need to check if our neighbor dictionary contain neighbor's direction contains direction dot down, and do remember that our starting rotation is to the right. So if we want to rotate our road end downwards, we need to rotate it by 90 degrees. That's why we need to set our rotation to be quaternion dot Euler 0 rotate by 90 degrees 0. And this would be our rotation that we need to apply. And we can copy this statement, type else, paste it, and else if we want to go to the left, to rotate left, we would need to rotate 180 degrees. And last case, let's copy this statement, and if we want to point upwards, we would in turn need to rotate by minus 90 or by 270 degrees. So this would ensure that we have created the road end. And one last thing we need to do here is to call our road dictionary at position, and we will need to make to add here or to assign here instantiate a new road end prefab. So our game object from this prefab, we are going to pass the position as the position, the rotation as the rotation, and we are going to pass transform as the parent transform for this game object to be instantiated. Now we can copy this name, we can open the visualizer script, and we can call the method fixRoad at the end of the for each loop inside our visualize sequence. So let's find the for each loop, and this is the end of it. So let's call road helper dot fix road. And this should instantiate our road ends at the ends of our roads that we have created. So let's save it. Let's go back to Unity. Okay. And let's click play. We can see if this works. Okay, and we can see that some of basically all of the ending roads have changed and are correctly rotated. Okay, so now we have to deal with the remaining parts of the road. So let's quickly go through it. So let's stop the game and go back to our road helper. Okay, so let's go down, and we have accounted for count equals 1 for the neighbor directions. Now, in the next count equals 2 case, we need to instantiate our corner. So let's copy this destroy statement, paste it here. Now we are going to do something similar as we did here. We need to copy those statements because we again need 3 statements because there is a default rotation for the corner as well. And now we know that our corner is rotated, I think, to the left and downwards, but we will see about that. Let's go back to Unity and let me check real quick. We can see the corner. Yeah, corner is rotated to the left and upwards. So rotation by 90 degrees now would mean we need to check if the neighbors are upwards and to the right. So let's go back to code. Okay, so what we need to do here is instead of checking downwards, we need to check upwards. And we can copy this statement, call and check if this is to the right. This means that we need to rotate the road by 90 degrees to fit those neighbors. Okay, so below we would have to check further. So if we have rotated to the right, so we have a neighbor to the right, and let's paste the same code, and we need to check if we have a neighbor downwards. This would mean we have to rotate by 180 degrees. And lastly, we would have to check if there is a neighbor downwards and paste the same formula and to the left. And this would mean we have to rotate by minus 90 degrees to fit those neighbors. And at the end, let's copy the statement for instantiating the road prefab from above, and we only need to change the road end to road corner. Great. Again, we can copy the same formula of if statements, basically with destroy. And this is our last case when we want to check for 3 neighbors. So again, as I recall, we have a 3-way street pointing upwards, downwards, and to the right. So by rotating it 90 degrees, we would have to have neighbors on the right, on the left, and downwards. So let's maybe visualize it to be more clear about it. So let's choose the 3-way, and we can see that if we rotate it by 90 degrees, we need to have neighbor right to the right, to the left, and downwards. Okay, let's go back to code. So first check would be if we have the neighbor to the right, downwards, another and statement. So maybe let's put it like this, and paste, we need to copy the same formula from above, and we need to check to the left. So this would mean that we need to rotate our prefab by 90 degrees. Now again, else if, when we need to rotate it 108 degrees, well, it needs to be downwards, a neighbor needs to be downwards, and to the right, to the left, and paste the formula upwards. Okay, so this would mean we need to rotate it by 180 degrees, and last case would be if we have neighbor to the left and we have neighbor upwards, up, and if we have neighbor to the right. Okay, save it, and instead of road corner, we will instantiate a road 3-way. So this should now work. Let's save it. Let's go back to Unity. Okay, let's try playing the game. And from what I'm seeing, we have the correct rotation and correct prefab in each position. Let's replay just to be sure. Yep, it seems like the road is placed correctly. So you had seen that it has taken us a lot of time to implement, but the effect is quite nice. So what is left now is to figure out where should we place our structures. And this is what we are going to tackle in the next video.